Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapkode. Dear students, come we will solve NEET questions on physics first PUC physics chapter number 9, that is mechanical properties of solids. Okay, we will solve some numericals on chapter mechanical properties of solids. Okay, so now I will move towards first topic of this particular chapter. So what is the topic? Stress and strain curve. Dear students, what I will do, I am going to solve one first NEET question on this chapter, that is question number 1. I will read the question first and I will tell you the answer and I will give the justification for that particular answer. Okay, now the stress strain curves are drawn for two different materials X and Y. It is observed that the ultimate strength point and fracture point are close to each other for material X, but are far apart for material Y. Full stop. We can say that materials X and Y are likely to be, in bracket they he has mentioned, respectively. First answer, ductile and brittle. Second answer, brittle and ductile. So third answer, brittle and plastic. Fourth answer, plastic and ductile. This is the question which is asked in NEET 2019, dear students. What is the answer for this question? So this answer for this question is B actually. What is the answer? That is B actually, brittle and ductile. Why it is brittle and ductile? We can see here now. Okay, you know already stress and strain curve, dear students. Okay, you know already stress and strain curve. We can call it as a stress strain curve. Okay, stress and strain curve. Okay, strain curve you know already. Then he has given material X and Y. Here X having 2 points, ultimate point and fracture point. Similarly material Y also having 2 points, ultimate point and fracture point. So here ultimate point for X is D, then fracture point we can take it as a E. Similarly the ultimate strength point for Y is D, again the fracture point for material Y is E actually. Now when it comes to material, you can see here now, this is what actually D, that is ultimate strength point. Then E represents breaking point or fracture point, we can say rupture point also. These 2 points for material X, these 2 points are very close to each other. If the ultimate strength and fracture point for material X, they are close to each other, then that X materials I can tell here as brittle. Okay, here I can tell it as a brittle. Okay, fine. Next, this is material X. If the point D and E, that ultimate point and fracture point, if they are too far away for material Y, then what we can say? We can say that material is ductile. Hence what I can say? The material Y is ductile. Why so? The ultimate point and fracture point are too far away for each other, then that material we can call it as a ductile materials. Hence respectively X and Y, right? Brittle and ductile. The answer is brittle and ductile. You can take here also ductile and brittle is there, but in the bracket he has mentioned respectively. Respectively means what? You have to identify first material, then you have to identify second material. First material is brittle, second material is ductile. Hence what is the answer? Brittle and ductile is the correct answer for this particular question 1. Okay, now I will move towards next question. What is next question, dear students? I will read the question first. What is that? So topic elastic moduli. Okay, now I will solve one NEET numerical on this topic. Question number 2. First I will read the question. A wire of length L, capital L, comma, area of cross section A, that is capital A, is hanging from a fixed support. Full stop. The length of the wire changes to L1 when mass M is suspended from its pre-end. The expression for Young's modulus is answer A, mg into L1 divided by AL. Answer B, mg into bracket L1 minus L divided by AL. Answer C, mg into L divided by AL1. Answer D, mgl divided by A into bracket L1 minus L. This is a question which is asked in NEET 2020, dear students. Now we need to identify the answer here now. How to determine the answer? The answer I will tell you here, dear students. Answer is what? Second answer is D actually. For second question, answer is D. Okay, for this question answer is D actually. How it is? Why it is D only? Then come, we'll see that now. Okay, now initially what we done, so here what I will do, I will take, it is one end is free, right? It is freed. Okay, now here from it is, there is a wire, you can call it as a wire. Okay, fine, there is a wire, then it is a mass actually. That mass I will take it as a capital M. Okay, initially the wire length of the wire is, you can take it as a L. Due to application of mass M, the length of the wire is changed to L1. From here to here it is what? L1, dear students. Now then there is a change in the length. That change in the length I can write it here as a delta L. What is delta L, dear students? Here delta L is equal to the final length of the wire, that is represented as a L1. He is telling in the problem itself. What is that? You can see here now. Due to application of mass M, the length of the initial length of the wire, that is L, is going to change to L1. The length of wire is going to change from L to L1 due to application of load M actually. The same thing I am doing here now. Due to application of M, the length of the wire is changed to L1. The initial length or original length of the wire is L actually. If I want to get the change in the length, then what I can do now? Delta L is equal to final length of the wire minus initial length of the wire. That is what? Delta L is equal to what I can write? L1 minus L. Final length of the wire to the initial length of the wire. That is delta L is equal to L1 minus L. Okay, fine. Now, how it is that now? We need to calculate the Young's modulus for this particular problem. We know already Young's modulus. What is that Young's modulus? That is Y is equal to, Young's modulus is represented by capital Y, that is equal to stress by strain. What is stress? Now I will write it here now. We know already equation for stress. What is that? F by A. Okay, fine. Next, divided by what? What is strain now? Strain is nothing but what? Or it is the ratio of original length to the change in length. Then I will write it in simplified form. What is that? Capital Y is equal to Y. What I can write now? F divided by A. Then into. Okay, sorry. It is what? Ratio of change here. Just correction. It is a ratio of what? Just a minute. Okay, fine. Okay, it is to L actually. Okay, fine. Now, Young's modulus is nothing but what? It's stress by strain actually. Stress is nothing but what? F by A. Then strain is nothing but what? Change in change in length to original length. That is a ratio. Then what I will do now? F by A is equal to, then it will come to the numerator, that is L divided by delta L, dear students. Okay, fine. So therefore what I can do now? So therefore what I can write now? Okay, what I can write now? So I will write it here now. Y is equal to, what is F actually? That is a force, right? That force I need to express in terms of Newton, because mass he has given in terms of kg. If he is telling mass, that will be in terms of kg. That kg I can convert it into Newton. How we can calculate now? So that F is equal to what? M into G. I need to multiply gravitational constant with the mass. I am going to get the force, that too in Newton. Hence what I can write now? We have taken M into G, but here M he has given capital. So capital M into G, then divided by what? A multiplied with what? This is what? Initial length, that is L, to the original length, that is delta L, dear students. Now already I told you what is y. Y is equal to capital M into G divided by, it is, again I am going to multiply this, that is capital L divided by what? A. What is delta L, dear students? Delta L we know already. What is that? Final length minus initial length. This is what my final answer, dear students. Now what is the final answer? You can see here now. Final answer is equal to capital Y, that is Young's modulus is equal to mgl divided by A into L1 minus L. That is what here you can see here now. This is what our correct answer, dear students. Now okay, this is what our correct answer, m into g into L divided by A into L1 minus L. It is our correct answer, dear student. Hence answer D is correct. Answer D is correct. M into G L divided by A into L1 minus L. This is the answer for this. Now I will move towards next question. What is the next question? Okay. Question number 3. When a block of mass capital M is suspended by a long wire of length L, the length of the wire becomes L plus small l. That means what? It is what? Change in length actually. This is what capital L represents original length, small l represents change in the length. Full stop. The elastic potential energy stored in the extended wire is answer A 1 by 2 into capital MGL, answer B MGL, answer C MGL. Here small l, here is a capital L. Okay, then answer D is 1 by 2 MGL actually. So he has given the same answer now. Okay, so he has given 4 answer. In this 4 answer we need to determine the correct answer. This is the question which is asked in 2019, dear students. Now what is the answer for this question? The answer for that question is what? The answer for that question is D actually. Third question answer is D actually. The third question answer is D actually. That is 1 by 2 into M into G into L. Why it is? Come, we will see here now. Okay, fine. Now we need to calculate the energy stored in the wire. To calculate energy stored in the wire, we know the equation. What is that energy stored in the wire equation? That is capital U is equal to 1 by 2 into stress into strain into volume. This is the equation we are going to use to calculate the energy stored in the wire. To calculate this, what I will do, I will try to calculate this, what is stress, what is strain and what is volume for that particular wire. So first, what is stress? Stress we know already, dear students. What is stress equation? Stress is equal to F by A. What is F? I already told, M into G divided by A. This is what stress. Yes, first is over. Next, what is strain? Strain is nothing but what? Dear students, you can see here now. Okay, here. What is strain here now? Strain you can write it here, right? Strain is equal to change in, it is a ratio of what? Change in length, that is change in length divided by what? Original length actually. Change in length to the original length actually, dear student. Okay, fine. That is what? It's the ratio of strain is equal to, it is the ratio of change in length to the original length. So now I will write it here now. I have written it here, right? 1 minute. Okay, we know what is delta L, change in length, right? That is what? Change in length I have marked here as a small l. So what is actually change in length is nothing but what I already told, final length. What is final length? I marked here. Initially the length of the wire is L actually. Due to application of mass or force, the length of the wire is changed to L plus small l, where small l represents what? Change in the length actually. So that how I can write it now? Delta L is equal to, we know already, L plus small l, this is final length, then minus initial length, that is L, divided by what? Original length, that is L. Then what happens here now? It is plus L and it is minus L, then it will get cancelled. Then the strain is equal to, what I can write it now? Then strain is equal to, I can write it here as a small l divided by capital L. Small l divided by capital L. This is what? Our strain. Yes. Then second term is okay. Yes, stress second term that you have calculated, that is strain, small l divided by capital L. Then what is volume? Volume we know, area of the copper wire multiplied with length of the copper wire, we are going to get the volume actually, dear students. Now what I can do now I will substitute all the values here, stress, strain, all values I will substitute here now. Then what happens now? It is 1 by 2, this is equation 1 by 2, this stress already I calculated, mg by a I got it here, yes, fine. Then strain is small l divided by capital L, small l represents change in length, then capital L represents original length, okay, fine. Now what we can do here, dear students, here a is there, here a is there, both will be get cancelled. Here L is there, capital L, here capital L is there, get cancelled. Then remaining term is what? 1 by 2 into m into g into small l. Yes, 1 by 2 into m, capital M into g into L is the correct answer. This is the what? Energy stored in the wire due to application of given load. Hence answer is what? This is the correct answer. Answer 4 D is the correct answer for this question, dear students. Okay. I hope you understood today's numericals. If you really understood, please do like, comment and subscribe and support me. We will continue in next video. Thank you.